Today, you will identify sampling methods and bias in surveys. A census is a sample that includes the entire population. It can be impractical or impossible. An example of this would be the U.S. Census that is done every 10 years to estimate the population living in the United States. A simple random sample is when individuals chosen have an equal chance of being selected. This is the sampling standard. What we do is we assign individuals a number and use a random number table or a number generator to select the sample. The easiest way to look at this, let's say in our class, I give every student a number, or I write their name on little slips of paper. I put them in a bucket. I reach in that bucket and take out one name at a time until I have like a sample of 5. That would be an SRS because each student has an equal chance. Our example here says, choose an SRS from the 5 of the following students using the 2463 as our seed value. So the first thing we will do is we will assign each student a number. Okay, so I'll start, and because we have more than 10 students, we have to include zeros. So Abby 1, Ellie 2, Ashley 3, Renee 4, and etc. So notice each student in our sample has a number, a 2-digit number. Now, you could have numbered this way, and that would have been okay. As long as you're consistent, it does not matter how you number. The next step, once we have all of our numbers, is to set up our random number feature in our calculator. Remember, we're going to use our seed value. In our example, I have 1, 2, 3, 4. So I'm going to just change this to 1, 2, 3, 4. Remember, you're going to push 1, 2, 3, 4. Then you're going to push the STOW or the store button. Then you're going to select math, highlight PRB for probability, and then you're going to select option 1, rand. Then you'll hit enter, and then the number, our 4-digit number we typed in, just randomly popped up. Now the reason why we seed our calculator, remember, is so that every single person has the same sample. If we do not seed our calculators, every single person will have a different sample. After we've seeded our calculator, now we're ready to run our random number feature. So I'm going to hit the math button. I'm going to highlight PRB for probability. I'm going to select option 5, random integer. And remember, I want it to be my first number, comma, my last number. And usually I can close my parentheses here and you won't need this extra 1. Once I hit enter, it will pull up a 1. So what that means is person number 1, Abby, is in my sample. When I hit enter again, I get a number 3. So that means Ashley is in my sample. If I push enter again, I get person number 2. So that means Ellie is in my sample. Okay, so if we push enter again, we get a 1, but we've already used a 1, so we skip it. Remember, we crossed them out, the ones that we used already? If I hit enter again, I have person number 7, so that means Haley is in our sample. And if I push enter one more time, I get 13, and that means John is in our sample. And that is how I select a sample using my calculator. A stratified random sample is when I break my population into strata or groups of like individuals, and then I do an SRS within each sample. So notice in our example, we have the population of election state divided into urban, suburban, and rural. The urban, suburban, and rural are my groups, and I do an SRS within each of those groups. When we choose our groups, it's based on facts known before our study, and the individuals in each group have to be similar in some way. So if we wanted to look at where high school graduates are doing currently, we don't want to include them with elderly farmer man. In this example, suppose we want to learn how students feel about funding for the football team at a large university. Note that the campus is 60% men and 40% women, and we suspect that men and women have different views on the funding. Why should we not use an SRS? Well, we don't want to use an SRS because we aren't guaranteed to have a proportional sample, meaning I want my sample to be 60% men and 40% women, so it's representative of the population. An SRS does not guarantee it. We could pull a sample of 90% men, we could pull a sample of 80% women, just because every person has an equal chance to be selected. How can we improve this sampling if we want a sample size of 100? Well, we could do a stratified. And because I know 60% of my population is a guy, we want to do an SRS of 60 men and an SRS of 40 women. So our two groups here are, well, the groups are the men and the women, and I do an SRS within those two groups. A cluster sample is different because it groups a population, and then we randomly select one group and ask everyone. Now, it's important that your cluster, each group should represent the entire population. So for example, if I know all freshmen are housed in 10 different dorms, and I'm doing something in regards to the freshmen, I could select a dorm and sample all of those residents. A systematic sample is easiest to remember. This is when a sample is drawn systematically, okay? For example, choosing every 10th person in line. Now, this can be okay when our order does not relate to the variable itself. The next sampling method is called multi-stage. This is when I have a sampling method that combines more than one sampling type, okay? Most surveys conducted by professional polling organizations such as Gallup use some form of combination of stratified and cluster sampling, and usually an SRS. So our example here, a national polling service may stratify the country by geographical region, select a sample of cities from each region, and then interview a cluster of residents in each city. Note that we've combined stratified by country. We did an SRS of cities from the region, and then we interviewed just a cluster of residents in each city. Here is our practice with sampling types example. Take a few minutes to see if you can figure out which sampling methods go with each problem. Now that you've tried, if I'm picking every 15th passenger as people board the plane, this is your clue that this is a systematic sample. Number 2, if I am choosing from a boarding list 5 people randomly flying first class and 25 other passengers, I am breaking up ticket holders by first class and coach. This is our stratified sample. If I'm randomly generating 30 seat numbers and surveying the passengers who sit there, that is your SRS. If I randomly select a seat position, meaning either right window, right center, right aisle, etc., and survey all the passengers sitting in those seats, that is my cluster. And if I stratify passengers by category, meaning flight crew, first class, or coach, Select a random sample of 2 categories and survey all those people. This is our multi-stage. Bias is defined as when a system systematically favors certain outcomes. The first type of bias we have is undercoverage, and this is when we're missing parts of the population from our sample. For example, in the U.S. Census example, households could be missing people that are incarcerated, students off to college, and people who don't have homes. Non-response is when individuals refuse to cooperate, and this is unique to humans. Response bias is when the behavior of the subject or interviewer biases the responses. This could be lying about illegal behavior, how the interview is perceived, and telescoping. Telescoping is when you're trying to get people to answer your questions in a certain way. Another example of response bias is how questions are phrased. Confusing and leading questions produce bias. For example, does it seem possible or impossible to you that the Nazi extermination of the Jews never happened? This is an example of response bias because of this. Because possible is stated first, 22% of readers said possible, but once our question was rephrased, only 1% responded possible. Voluntary response bias is a form of bias, and it is also a form of sampling. This is when individuals choose to participate based on appeal. Usually those with strong opinions are more likely to respond. Examples are call-in, TV, and radio shows. Okay, they're asking people to call in and voice their opinion. Another example of poor sampling. You are trying to find out what freshmen think of the food served on campus and have thought of a variety of sampling methods, all time-consuming. A friend suggests that you set up a Tell Us What You Think website and invite freshmen to visit the site to complete a questionnaire. But what's wrong with this? Well, because we are asking them to choose to tell us what you think, they have to go online and fill out the survey. So by allowing freshmen to choose makes this a voluntary response sample. Students who are often dissatisfied with the food are more likely to go online and respond. And this gives a biased view of the opinions of all freshmen. Another form of bad sampling is called convenient sampling. This is when the researchers choose people that are easiest to reach, often results in undercoverage. And remember, it's a sampling scheme that biases the sample in a way that gives part of the population less representation than it has in the population. An example of this would be mall surveys. I remember I used to go and Gallup people would be there, and they would just come up to you and be like, hey, can you take this brief survey for me? That's an example of convenient sampling. It's convenient for the researcher. That's all I got. Here's your assignment.